Our first video in 9.6 is going to be solving by completing the square, and then the second video will deal with using completing the square to create vertex form. And I want to just put 4 words that you need to know: roots, zeros, solutions, and x-intercepts. When we talk about those 4 words, they all mean the same thing. It's just how we get them. So roots is when we're square rooting to get the answer. Zeros is when we have an equation equal to 0. X-intercepts, where y is 0. We're trying to find out where it crosses. Solutions, they're all the same thing. When I'm looking at a parabola, solutions are these things right here. Where do I cross the y-axis? We just call them different things based on what we do to find them. So we're always trying to find those 2 points whenever you see solve. So let's take a look at that first example. And when we were doing sneaky squares, we noticed that we're going to kind of ignore the equals 22 here. If I take half of the middle and square it, I should get the third value, that constant. If it is, then it's a perfect square. In this case, if I take half of 18, which is 9, square it, I do not get 8. So this is not a perfect square. So I'm going to complete the square. So what I want to do first, I want to get that minus 8. I want to move that because that's not part of a perfect square. So I need to move that to the other side of the equal sign. So I'm only dealing with what I need on the left-hand side. So minus 8 is really plus 8 will cancel that out. So I get 3x squared plus 18. And that all equals 30. And we know, just by basic math we learned in elementary, that 3 is not a perfect square either. So we can't really have the 3 there because there's nothing squared to get 3. So let's divide everything by 3. So as long as you do it to the whole equation, you can do it. So 3 cancels out and I get x squared. 18 divided by 3 is 6. Oops. Forgot my x up here. X squared plus 6x, and that equals 10. And now what I can do is make my own perfect square. The thing that's missing is right here. I don't have a value that makes this a perfect square on the left-hand side. So what I need to do is create that. And what we learned in sneaky squares, I can put an x squared here, and I know that if I split 6 in half, I can start creating a perfect square. So that means that these 2 things are x. I know that 3 times x and 3 times x. So I have a perfect square because it's x plus 3 on one side and x plus 3 on the other. Now I just need to know what is the part that I'm missing. Well, I'm missing this part. 3 times 3 is 9. I'm missing that piece. So let's take 9. It's a positive because it's a square. And I'm going to add it to the left side because that makes this a perfect square. The only problem is when I just add in a random 9 on the left, it creates a whole different equation. So what I need to do is cancel that out and put a 9 on this side. Whatever I do to one side, add 9. I do to the other, add 9, and it doesn't change the actual equation. Because really, if I subtract 9, they both cancel out. So I haven't really changed the equation at all. So if I'm looking at the perfect square piece, this side now becomes x plus 3 times x plus 3, which is a perfect square. And that equals 10 plus 9, which is 19. And now it looks like we did before. We have a squared on this side, and I can just square root to cancel that out. A square at the other side, I get plus minus. So I get x plus 3 equals positive negative, that's a 19, square root of 19, and then I subtract 3 from both sides, and I get x equals negative 3 plus or minus square root of 19.